Hello and welcome to the March update from the Tau team. You're here with me, Fola, and we have a member to introduce today. So without further ado, I'm going to pass it over to Karim for his overview this month.
Thank you, Fola, and welcome everybody to our March call. This is a quick summary of the development progress here at IDNI. Maurici has been working on the optimizations for TML. One of them is called BDD caching, and he's been experimenting on the cache hit ratio. And so far, actually, the results are not good as we had hoped, but there's some things to learn there. So you don't always get what you want from optimizations. That's kind of a fact of life, but we're working on it. And hopefully the BDD caching algorithm will one day become a core part of our technology and a very good optimization. We have confidence in that. Tomasz has continued to work on the TML IDE that you all can access publicly. So that's progressing well, but most of his time has been spent on TML built-ins. That's because we found some bugs with TML built-ins, and we're also trying to optimize those. Juan, from his side, has been working on the bridge between Binance and the Ether blockchains. And that bridge is necessary because what we'd like to do is we'd like to give our users an option from paying the very high gas fees on the ETH blockchain. So we would like to set up a parallel chain with the Binance system. That way we can have, our users can have access to much lower transaction fees when they're trading Agoras tokens. He's also continued working on the second order logic that he was the original developer of at the beginning, and him and Luca have are basically working on a new algorithm that Ohad has given them. So they're doing that in parallel, each with his own implementation. He's also gone back to working on the arithmetic feature that he implemented before, and we have some new optimizations for that. So he's re-implementing the arithmetic. But I would say on the Agoras side, on the Agoras Live side of things, there's been some very good progress. Andre has managed to integrate a cryptocurrency wallet into the Agoras Live application. So for the first time in the history of Agoras Live, we're able to process payments. So the goal is to be able to integrate more standard wallets that are very popular out there. So to make it easier for people not just to buy and sell Agoras Live tokens, but also would serve as a fiat on and off ramp. So you can use your credit card eventually to be able to buy Agoras or other cryptocurrencies and sell your Agoras for fiat. So that's a major development. Hopefully Andre will be able to demonstrate that here in a minute. And Moaz on his side has been working on a complete redesign actually of the Agoras Live, what we're internally calling Agoras Live 2.0. And to that end, we're actually onboarding two new developers. One developer on the client side, development for web client side development will come on board to help Andre with the client side development of Agoras Live. And we're also hiring another very important hire who's going to be working on the blockchain development and mainly our mainnet, but also on some cool new features of TML that we'll tell you about next month. And last but not least, we have a new member of our academic advisory panel. His name is Professor Christoph Benz-Müller from the Freie University of Berlin. Professor Benz-Müller is a world-renowned expert in the fields of higher order logic, reasoning, and theorem proving. And we're very excited to have him on board. That's it for my overview. I'll let the team give you the details. Thank you.
So I assume roughly just a few minutes, right? I could, of course, give you a longer introduction about my work, but just a rough overview on also probably the CV. So I'm in the field of AI since the beginning of the 90s. I studied in Saarbrücken, which is one of the major places for computer science and artificial intelligence in Germany. In particular, at the time, there was Jörg Siegmann, who, as far as I'm aware, got the first professorship in AI in the 80s already. And then there was the Max Planck, not the Max Planck, the Deutsche Forschungszentrum für Künstliche Intelligenz built up in Saarbrücken, and also Max Planck Institute for Computer Science, which created an excellent environment at the time for studying. I got interested in the big questions, actually, in a course on artificial intelligence when Jörg Siegmann challenged us with this vision that there is a new branch arising in evolution, which is built on different biological foundations as we are used to, and meaning computers, which then eventually will even be able to reproduce themselves and so on. So I said for myself, no, I don't believe that, but I got very much interested in studying exactly the boundaries of what can be achieved on computers and what makes us humans very special or not. And so I dived into the area of automated theorem proving in mathematical context, because I thought that is one of the challenge areas where we humans are particularly good at. And if I could make progress there or get a feeling for how far you can, in principle, get in this area with computer technology, then this is also one way to approach these big questions of whether there are fundamental differences between humans and machines. So that is where I come from. But and of course that triggered this research already as part of the PhD thesis on automating higher order logic for applications in mathematics, mainly at the time. And that was the reason why I was developing these theorem provers, Leo, starting with Leo 1, later Leo 2 in Cambridge then, and recently now more by my students, in particular Alexander Steen, the Leo 3 prover. So the initial motivation was automation or interactive and automated proof with in mathematics, this combination. But then I found out that the mathematicians are not really too much interested, and still not are, in applying such a kind of technology for many good reasons. So it will eventually be the last class of persons out there who are open-mindedly switching to this new form of interaction. Well, you see many people now doing interesting work in the area, like at Carnegie Mellon University, or Kevin Buzzard in London, and so on. Many interesting mathematicians who do interesting work. Also Thomas Hale's impressive work. But I focused more recently then on this aspect or this challenge of non-classical reasoning, expressive non-classical reasoning, and that is why I also was very much inspired by the project here, the description of the Tau meta language and so on. So the applications in areas like legal, ethical reasoning, and in particular for a long time, interested in the area also applications in direction of contract languages in general, smart contracts and so on. And of course, I think here we are very much aligned with mutual interests. And I think that from this higher order perspective, we have developed an environment where we can embed many, many interesting non-classical logics as you need for many of the applications. And now the question here is from the other side, again, what is actually needed if we want to keep them decidable. So how much, for instance, of the ideas and work we have studied can be, let's say, converted into a context in which decidability is a main criterion. Because for me, that hasn't been so much so far in my work. I was just interested in, can I do something with these techniques in practice, do practical examples run? But this is now an interesting, let's say, challenge question to look at, and whether some of the machinery we have built up can be fruitfully employed in exactly the context of the projects here. And I think that's enough for the moment. I mean, I could go on and talk now about non-classical logics and all that for a long time, but I think that's not the interest of the meeting here.
All right, thank you so much, Professor Bensmuller. It's fantastic to have you on the team. And it's gonna be great working alongside you. But let's pass it over to Luca for his update this month.
Thank you very much, Fola. So in the beginning of the month, I familiarized myself with the TML language itself, actually. So I wrote a little program that decides whether a given relation carries a group structure or not. From there on, I started exploring an algorithm where the idea which emerged from OHAT is that the second order quantifier can actually be seen as an interval of relations. And then the instances of the relation that is quantified over in a formula can actually be seen as constraints on this interval. And so I was trying to get a good grip on this idea, which included studying Boolean algebra quite a bit in order to see whether we can use this perspective to actually come up with an algorithm to efficiently solve second order formulas. So one of the steps that I took was to spell out the basic BDD operations like AND or negation on intervals of relations instead of just on one Boolean function. And then the next step, which is kind of where we are at the moment, is the interaction between the first order and second order quantifiers. And all of these processes was accompanied by discussions with Christoph Benzmüller and OHAT in weekly meetings we had. And so this is roughly where we are at now. We haven't solved it, but we got a good deal done, I would say. And then I also started looking into how we can use SMT technology to solve the query containment problem, especially with an emphasis on a conjunctive query containment with negation, because algorithms are quite hard and slow, and we want to see whether theorem proving in that sense can help us here. And this is what I'm currently also investigating. So that is my update from the month. Thank you very much for listening.
Thank you very much, Luca. And now I will pass it over to Tomasz for his update this month.
Thank you, Fola, and hello, everyone. This month I've been working on built-ins and a little bit on the editor. Let me show you a glimpse of what you can expect soon.
So all these are just proposals and can change anytime later. So for printing we have print built-ins. Print uses standard output, which is available here as the output top. For example, here is a hello world. You can use variable number of arguments and they get printed one by one. There is no new line character printed by default, so you can see it's just concatenated into one line. So if you want to a new line, you can print it explicitly, like this way, or you can use print line. Also, there is a possibility to print to another output than the standard one, so you can print to dump. Let's see. And you can even print into the error output. You can print. You can use print delim or print line delim, which expects delimiter string or character as the first argument. And you can also see there's a print or print line to delim, which expects the name of the output as the first argument, delimiter as the second argument, and then there are arguments which are going to be printed and delimited. So let's see into the dump. You can see a printed hello symbol, space as the delimiter, and world. Be aware that execution of rules, the order of built-ins is not guaranteed. So we can print greetings, space, world, and the exclamation mark. So if I run it and check the output tab, you can see the order is different, and each time I run the program, the order can be different. So for this, you can use built-ins in the body. So let's see. Here is a body which contains 4 built-ins, and the order of the built-ins in the rule is guaranteed. This is just a removing of a dummy, which is just to make it a rule, and there is no dummy, so there is nothing removed. You can see the order is fine now. If you have a head built-in in a rule, built-in is run each step the rule is through. So let's see, when I run this, the reason it's printed twice is that each program has to run at least 2 steps to determine if a fixed point was reached. So the rule gets executed twice. To trigger the rule only once, you can make its body false by removing its condition. So we can maybe remove the printing from the database. And when we run it, it gets run only once. So let's move to another built-in. Another built-in is built-in halt. It is for ending the program programmatically. You can see there is a relation A with 0 in it at the beginning, and with each step we remove the number and add another one. Then we remove the 1, we add 2. We remove 2, we add 3, and this we go up to 5, and when there is a 5, we remove the 5. So when I run this program, you can see that anything which is in A, it gets printed to the dump output. So let's run it. You can see it prints 0 to 5. But then when we add this rule, we say if there is a 3 in the relation A, halt the program. So when I run it now, you can see it gets printed to up to 3, and then there is a dump of the 4 in the relation A. The reason there is this 4 is because the step when there was 3 in A is finished. So you can see that even if there is a halt, all the rules which are executed in the step are finished before the halt happens. Another built-in we can use is the contradiction. You can programmatically put the TML into the contradicting state. So we can, for example, say that if there is a male, if something is a male and female at the same time, it has to be a contradiction. So we can have John to be a male, and we run it, it works fine. When we say John female, it also works fine. If we say male and female John, or that John is male and female, it says contradiction. Last thing I wanted to show you is that if you are running TML in browser, you can access browser's JavaScript engine and even access browser's API and DOM. There is an experimental built-in called Jseval. It concatenates all its arguments and evaluates it as JavaScript. Here I created a simple TML program which provides 3 different frequencies, and there is a Jseval call which is executed for each frequency in the relation, and this JavaScript then uses browser's window audio context. So let's try it. One thing to notice here is that browsers DOM and window global is accessible only from the main browser thread. If you run TML in the background, it is implemented as a web worker which does not have access to pages DOM or globals like window. For that reason, you can choose if you run TML program in the main UI thread or you want to run it in the background. So this button is for running in the background and this one is for running in the foreground in the main UI thread. So this works just fine because it has access to window, and this does not work because it's in the background and does not have access to globals and DOM. So that's all from me this month.
And I will now pass it over to Maurici for his update this month.
Hi, fella, thank you. This month I did a mix of things. The first thing which I was doing was improving the performance of the transitive closure algorithm. So basically, this involved identifying certain data the transitive closure algorithm involved identifying the certain bits of data which we thought would improve the performance of the program if we memorized. So I spent the beginning of this month just trying to see if I could find better subsets of data which you could memorize in order to improve performance. And I identified some identified some effective subsets where I could actually reduce the amount of cache misses in the transitive closure cache by 20%. And then after that, after identified some appropriate sets for caching, I spent some time looking into how I could update the cache faster, because even though the cache had the correct data to reduce the amount of cache misses, updating the cache turned out to be quite slow. So I was investigating various algorithms for updating the cache faster, so that we could achieve faster performance overall for TMR programs. So that was one of the things which I worked on. Another thing which I worked on was hashing, was improving the hashing performance for a different cache. So the first cache which I mentioned was one kind of cache. We have another cache which stores vectors of binary decision diagrams. So one of the kind of performance bottlenecks was that hashing these vectors was slow. So I worked on algorithms to memorize the hashes of these vectors, so that not so much time is spent recomputing the hashes of these vectors each time you want to do a cache lookup. Some other things which I worked on include disabling the support for unsafe negation. Upon measuring the performance of these TMR programs, or had identified that he identified that that unsafe negation was causing some performance slowdowns for certain programs in TML. So one thing which I did was disable unsafe negation support, and this caused quite some speedups for certain programs, especially ones including Jseval. And I guess this also span off, this kind of investigation also span off some research into subsets of data log with first order logic, fragments of data log that are safe. And this is a bit of a hard problem to correctly identify whether a certain data log program is safe or not, where safe implies that that the queries are domain independent and that the results of the queries are finite. Yeah, and I guess apart from general bug fixes, another thing which I've started work on includes variable shifting optimization, which basically involves looking at various BDDs and seeing whether they're kind of similar to each other, apart from whether certain BDD binary decision diagrams are similar to each other modulo a certain offset. So I began working on the algorithms for that optimization, and we'll hope to see whether this causes great performance improvements for next month. Thank you.
We have another member of the team to introduce. His name is Lucas Saul, and I'll let him give an introduction and his thoughts on the project.
Yes, I'm Lucas Saul. My background's actually in physics. I did some space science work, encountered blockchain for the first time when I was working on the Interstellar Boundary Explorer project. And a few years later, I thanks to Killian, I met Ohad in IRC chat. And over the last couple of weeks, I've been coming up to speed with the IDNI projects, some interesting research going on here. And so I've been catching up on some of the logic that I need to know to understand something about TML and how we can put this on a blockchain, and looking a little bit at some consensus methods, looking a little bit at proof of stake, because with the types of voting we need to do, there will need to be some sort of staking going on. I have some ideas to put forward. Some of the parts that excite me about this project are the ways that the code can manage itself, so to speak. So there's a versioning system which is inherent in the system itself, and it's a compelling idea and will enable it to grow in interesting ways, perhaps. So yeah, so a little more about my background. Worked with a few different blockchain projects, developed a Woodcoin chain, and worked with a stablecoin project called Vault briefly. Worked with Vermont Secure Computing. There's a couple projects we had to develop hardware wallet. And so that's my background's mostly in C++, a little bit of Java. So it's going to take me some time to come up to speed with the TML project, but I'm excited to be here and work with you guys, move this thing forward.
Thank you very much. It's a pleasure to have you on the team, and have you do the great work and work alongside us. And so yeah. So next, I'll pass it over to Andre for his update this month.
Hello everyone. Last month I was finishing testing our Agoras Live platform, fixing some minor issues, for example with calendar, but now it's done. But prior giving away that testing to professional tester, we lack one very significant part. It's the payment system. While we have micropayments and our mainnet in the works, I've implemented a payment system based on web wallet. Let me demonstrate to you how it works. For example, let's create a new account. Great, now we have our account created, but in order to make sure that the user is who he is, I've implemented a system that requires a wallet signature. It works that way. From the backend, I request a user to sign a message to make sure that he is who he is, that he owns a wallet, the wallet he logged in with. Okay, everything is confirmed and we're registered. Now we can use our platform, browse through users, make calls, attend to grub sessions, etc. etc. But let me show in depth how it works using the account I have money on. Okay, we have an appointment, a test appointment with Albert Einstein. Let's try to call him. It requests if I'm ready to pay a certain amount of our token over Binance Smart Chain, and it's working. The fee is not that high, in reality it's like 20 cents. I increased the fee intentionally for testing purposes. The window in the production will look like this. Let me show you. But prior paying, let's log into Albert Einstein account and check his wallet balance. And here it is. This is our own coin over Binance Smart Chain testnet, and this is the amount of money Albert Einstein has on his wallet. Now we're going to pay for the session with Albert Einstein prior entering a call with him. It takes only a small amount of seconds to put the payment to the blockchain. And now we are ready to join the room. In the room itself, Albert Einstein will get the hash of that transaction and check if the amount of money user paid to him for the session is the amount of money needed to attend to the class. And also, of course, he will check if the transaction was successful right on the blockchain. Now let's update his balance and we'll see if Albert Einstein got his payment. And here it is. He got his payment. Adding money to the wallet is also easy in the cryptocurrency wallet. It is done directly with credit card or by transferring money, for example, from the exchange or your another wallet. That's pretty much it for this month. Next month I plan to move payment system to the production mode and give Agoras Live to external testing. Thank you all. Bye.
Okay, thank you very much, Andre, for your update this month. I will now pass it on to Juan for his update this month.
So hi, Fola. Thank you. Well, this month I focus on 3 different threads. On the first one is on the blockchain side. As Andre mentioned, we are moving forward with integration with the Binance chain. So over there, we also have a micro payment channel being tested, which is pretty much the same payment channel that we have been working on the Ethereum blockchain. And what I mainly review is the cross-chain mechanism in order to be able to make Ethereum and Binance Smart Chain interoperable. From there, there are already available solutions which are known as bridges on the Binance infrastructure, but we are still reviewing this because we may eventually provide our own interoperability mechanism. Sorry for that. So that's on the payment system / blockchain side. And on TML, I'm also pushing forward trying to push forward the second order logic feature. I'm sort of walking a parallel path with Luca. Everything, or my understanding is that everything is related about constraining the power set or the domain for the second order variables. So from the matrix of the formula, we can infer constraints that involve what must be inside or what must be part of a variable of the solution of one of the variables, and what must not be part of that solution. So dual constraint or pair constraints may need to be negated. So I'm also really for exploring, as Luca mentioned, algebra concept that are somehow left in the past for several years, but reviewing algebraic concepts in order to model and to deal with these operations. And and that's we already had some one step forward. We don't have a systematic approach to constrain variables, but my understanding is that we do need to take an additional one in order to really solve the variable assignments or constrain properly the second order variables there. And that's only I would like to mention here that that's yet not addressing the quantification step. It may leave not I would say a straightforward scenario to handle the existential quantification, but not the interleaving of universal and existential quantification over the second order formulas. That's one side of the story, and also I'm returning to arithmetic because there are of course many feasible optimizations to be done in there. So I'm returning to arithmetic code basically to clean it, improve it according to our standards, and getting the feature more closer to a release status. So I'm also returning to that more than 1 year focus. One more year ago focus. So that's basically the technical work that I have been addressing during this month. So that's all from me by now.
All right, thank you very much, Juan, for your update this month. Next, I'll pass it over to Killian for his update.
Everybody. So this month, a couple of things happened. First, Full and I, we've been scouting a suitable copywriter for our project who can give a voice to the project. So that's been a challenge to find the right one. And out of those that we've been interacting with, there was in particular one promising candidate. But we still would like to interview a few more to make a final decision of who we are going to onboard. Then I've been also growing the list of YouTubers, did some outreach and follow-ups in that regard, but the response rate wasn't really great. Often when they responded, they were highly overpriced. But in particular, one candidate is promising, but he also currently has a lot of is quite busy. So yeah, I am still in contact with him, trying to find a good appointment that suits him, where we can introduce ourselves to him and see where this relationship will go to. I've also been working on the presentation of the project. It's getting, as usual, closer to a final version. For example, this time we kind of narrowed down the vision of what we are doing, and basically, well, you can see, or you can find various angles of how to look at our project. But what we agreed upon is that basically one can say that our vision is to advance humanity by scaling collaboration without compromises through logic-based artificial intelligence. Then in terms of the coin swap, we also updated the information on Etherscan and CoinGecko and the markets. So yeah, now if you look on Etherscan, if you look up the token, it actually shows all the information related to our project. Then we also had the AMA with Bittrex, where Ohad and I participated. Yeah, the AMA was a success. I mean, we got a lot of relevant information out, but also, unfortunately, the AMA was quite driven by bots. So the interaction with the Bittrex community wasn't as organic as we hoped for. But still, well, I transcribed also the AMA into our Medium. So if you want to look it up, there's a lot of valuable information about our project on the Medium. We also launched the Tau Supporter Program, which currently we have more than 20 applicants, and yeah, the program just launched. It's still, you're very welcome to apply for it. We are looking to scale the number of participants for the program, and yeah, the link for applying will be under the video. Yeah. And also related to that, I've been doing community support, in particular Meow with a U in the end. He was dedicated to create the German Telegram group, and Fuller and I helped him with that. And he's been really engaging a lot of the German community in that channel, which was really great to see. He also transcribed the Bittrex AMA to German, and there's been quite some engagement in the German Telegram group, so we're definitely appreciating that a lot. So also for that matter, the community member of the month is Meow, for his engagement. Yeah, and yeah, that's pretty much it from me so far. Thank you.
Thank you very much, Killian. And hi, guys. From me this month, been a number of different topics, sort of similar to Killian, working alongside him on the things that he's been working on. On top of that, been negotiating with Bittrex as to how this ongoing swap will function. There's still some details to hash out there. We hope to have that sorted out quite soon. But for now, Whitebit is still open if you do want to swap your Omni tokens to ERC20. And there's been a couple of questions in the community, sorry, in the Telegram channels as to how to store your Agoras tokens now that ERC20. You can use MetaMask or any other sort of similar wallet if you want. All you have to do is add the contract to MetaMask. There's many ways, many descriptions online you'll be able to add that will show you how to do that. But if you need any assistance, then just drop us a note in the Telegram channel. And as Killian said, that we've been looking for a copywriter. One particular person has stood out. Just to make sure that we're very happy with this decision, we are going to interview a couple more people, and just make sure that you know, we're really happy with them. But they are very good though, and it's very exciting to potentially have someone on board so soon. I've been also working with Andre and Karim looking for a front-end developer for Agoras Live. That's been going very well. We have narrowed it down to one person who has given us a quote to get it done. I believe there are going to be some minor changes, well, not minor, but simplification, I would say, of Agoras Live. So we haven't gone ahead with that just yet, but I'm pretty sure that we'll be able to do that quite soon. And then from designers as well, we are bringing on 2 designers, not 1 now, to work on this rebrand, logo, all that kind of good stuff that you guys have been waiting up for us to do. We've got 2 really, really good designers. And we've also found a website designer as well, separately. And they are really, 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 really high quality. And I'm really looking forward to working with them. So we're at the beginning stages of working with them. So sort of getting the juices flowing and making them understand the project. That's kind of at the stage we're at right now. And we've also begun working on our marketing as well. We have engaged with a marketing company. So we're actively working on this now. And again, very much like the designers, we're at the beginning stages of getting them to understand the project. And we've been really surprised with the company that we're working with. They've got really impressive backgrounds, and they really understand the crypto space as well. So it's been very good. And I had made a great comment on one of the calls the other day. He said, you're not going to be ready to market for us until you're convinced that this is the greatest project in the world right now. So, it's a really interesting, having some really interesting meetings with those guys as well. So beyond that, I've been onboarding Professor Bensmuller and Lucas, and still working on onboarding Dr. Kramer. Continue to push forward on that as well. And yeah, working on the typical administration that happens in the Tau project. So that's it from me, and I will pass it over to Ahad for his update this month.
Thank you very much, everyone. So this month I've been involved in everything, but and a lot of the usual things, but to highlight 2 things. With the discussions with Professor Fanconi, we basically hesitate between the 3 logics, OWL2 and guarded first order logic with least fixed point, and monadic second order. Once we settle on those, we will need to write solvers for them. And for writing solvers, I'm completely confident because one of the best things that ever happened to the project is the join of Professor Bensmuller, which is just the best man in the world for the mission of writing solvers. So I'm completely confident that we will nail it down very well. Another big thing that happened this month, which is really big news, is the realization how we can give a short certificate for in cryptographic level to a correct running of a TML program. And so, you know, to take an example, in Ethereum, everyone needs to write the smart contracts. Why it is not the case that one can run it and provide a certificate that they ran it correctly? Well, we'll be able to do so in TML. This is because TML is based on BDDs, and therefore the running of TML can very straightforwardly converted to a QBF formula that says that the running is correct. And using the sum check protocol and a proof that IP equals P space, the interactive proofs in polynomial time equals polynomial space, without cryptographic assumptions or without probabilistic a weakening of the problem, short proofs, polynomial proofs are NP. But if we allow probabilistic proofs, we can go up to P space. So that's really a big thing, that we will be able to, that one node runs a TML program and can convince all the others efficiently in a short proof that the run is correct. And this we will do with the help of Lucas, which is of course yet another great addition to the team. He knows quite much about cryptography and decentralized networks, and he will be leading this effort of creating a network of proven computations with, again, short, efficient proofs, which are probabilistic but are good enough from cryptographic point of view. And I guess that's all for now.
All right, thank you very much, Ohad. So please stay tuned for the Q&A, and we'll answer all your questions there. Thanks. And this question is from Dana E, and they ask, will Tau eventually be able to use natural language processing to turn unstructured data, speech, into structured data, speech, so that we can more quickly grow the knowledge base?
Yeah, well, currently no one knows how to do it, but due to the design of Internet of Languages and the overall design of Tau as being self-amendment, the day that someone will know how to do it, we will be able to incorporate it into Tau.
This question is from Stefan Gayler, and they ask, I asked myself, asking for a few lines in the protocol, if it makes sense to always follow the majority opinion. A single one can also be right, that the majority is not correct with your opinion, where remains the individuality of individual realism. See outstanding individual services of individuals. Has something been considered in Tau? Ergo, one page must be right, or there is a dualism, as there is a rating of right and wrong. Or in other words, is it meaningful always to follow the majority opinion? An individual can also be right and the majority is not right with their opinion. Where is the individuality of the individual correct opinion? See outstanding individual performances of single individuals. Has something like that been taken into account in Tau? Ergo, one side must be right, or is there a dualism? How does valuation of right and wrong take place?
There is no right and wrong over Tau. Everything is opinions. And therefore, there can, of course, be contradicting opinions. And now for the case that the majority is wrong, this happens also in real life, of course, but on Tau, we don't have a full solution, but we are in a better situation than real life because logical engine is able to detect contradictions. So sooner or later, a wrong opinion will run into a contradiction and by that be discarded. So in this sense, we are in a better situation than real life.
And this question is from DLT Novice, and they ask, how will human combined intelligence be used first in usefulness? AI seems to be running ahead. So which is more valid, insightful? Many humans fail the Turing test for me.
One comment from me on the Turing test. Well, I guess machines will get closer and closer to solving instances of the Turing test over time. And in some way, you could see that as a sign that machines are getting closer to human level intelligence. But on the other hand, I'm not really personally convinced of that. So my personal opinion is there will for a long time be quite a gap between human level intelligence and what machines can actually achieve. Time will tell us, but I think there is eventually still some fundamental difference. That doesn't mean that we can get in many single particular domains very close to human level performances and even dramatically exceed it. And I think that also includes applications in the area of checking arguments with technology, as we just discussed in previous questions. And this is a fascinating area.
And this next question is from DLT Novice. And they ask, there are so many languages, like human ones. Why are they different to achieve understanding? Can Tau answer that? Is it based in Hebrew? I think words are like a molecule and letters are atoms. Also, many computer languages are invented per domain purposes or ease or close to the metal fast, or functional procedural. What is the main future you're looking at for the use case of the Tau language? A meta language means what? Can you humanize your goal or compare it from computer language purpose to a parable for human languages?
I will only comment about the meta language part. The meta language is only intended to be able to define more languages. So many languages will be able to exist and evolve over the system. And for the rest of the question, I guess Professor Bensmuller has interesting things to say.
So I think what we also did in our works is to try to get arguments stated in natural language formalized in the computer. And this is in some sense quite independent, this process of the language you start from. So whether this is now a German or an English text or a Hebrew text, what we want to get out of such a process is a characterization of the essence of the argument in terms of an independent logical language, and check then whether this transformed essence of the argument makes sense, and making sense in terms of checking for rationality, for freeness with respect to contradictions, so no paradoxical argumentation involved here. And this is something you can do with the machinery. And in this way, you get in a way independent of the languages, the natural languages you start with, and you achieve an interesting independence and also then feedback in the different languages in terms of pinpointing problems of an original argument after a rational reconstruction on a computer.
And this next question again is from DLT Novice, and they ask, if I ask the Tau language after a huge collection of data, is COVID a scam, plandemic, what might be its answer? How could it truth us out of programming of TV?
Again, the best Tau can do, and philosophically also the best humans can do, is detect contradictions. We have no access, we don't have direct access to truth, but sometimes we can discover what is not true by detecting contradictions.
And this next question is from Felix, and they ask, what do you think about GPT-3, and could Tau chain benefit or compete with it? Would it make sense to request GPT-3 access, which is relatively open, to aid Tau chain development?
Machine learning is quantitative in nature, while logic-based AI is both qualitative and quantitative. Even things that look qualitative, that look qualitative, that are done in machine learning, like certain natural language processing tasks, are being forced into qualitative model, and that's yet another source of their inaccuracy.
Yeah, my viewpoint here is to this very interesting question, three aspects. The one is actually that the two areas might eventually fruitfully interact, and there should be more eventually people who look into that. And one way they could fruitfully interact is that logic, as we discussed already, should actually be in harness for machine learning approaches when it comes to really, let's say, critical applications, because logic can be precise, and this could provide a basis for verification and for making sure that things don't go in the wrong direction, even if there's a small likelihood we are talking about. So good trained models still have a rest of risk in a way. But then on the other hand, the logic area might benefit from machine learning in a way that when you integrate it, that you eventually can benefit from learning decisions in theorem proving, for example. There's a starting community in this direction, work that's relatively fresh that look into that area. And that's interesting to follow, whether, for instance, strategies for proving things can be learned by using a machine learning technique. So that's another aspect than providing logic as a harness for machine learning. And the third aspect to look at is actually the interplay between the two from the perspective of strong AI. So for me, the clue actually to strong AI, the big questions that actually motivated me personally to get into the field are related with the questions on how we actually can get from trained models, so from the statistical level, to sharp theories on the logical level, and eventually have a nice interplay between the two layers. And I think in this interaction is lies potential answer to the really big questions out there, how far you can go with AI-based approaches when you integrate the two worlds of machine learning and logic-based approaches. But for the moment, I think we should pay attention that the logic-based side is the one that can give us really security and verification aspects and so on. And this area at the moment needs to be fostered. And at the same time, eventually we could keep our eyes open for potential integrations.
And this next question, and the last question, is from Dana. And they ask, will Agoras Live be implemented any gamification elements to take advantage of tokenomics? What is the strategy to increase stickiness or long-term user engagement? And how can we use the Agoras token?
So yes, on Agoras Live, we don't have any gamification for now, but in general, one aspect that can be seen as gamification on Tau is debates, that people are able to have debates, in a form of game with winners and losers and challenges and maybe even money. So that's one form of stickiness to the other part of the question. To mention another point for stickiness is because the system can detect when you contradict yourself. There is a well-known result in psychology called Festinger's cognitive dissonance, that shows that people have deep psychological need to remain consistent and get into psychological stress when they see contradictions. So I'm sure you can imagine that whenever people will see that what they said it contradicts itself, they may obsessively try to fix everything to make everything consistent.
Thank you very much, Ahad, and for everyone participating in this Q&A. And thank you to all of you who have sent us in questions. We look forward to receiving more every month. So please be active in the community channels. And the Tau supporter program is live and available. So reach out to Killian on Telegram if you want to join. Yeah, that's our update this month. And thank you very much.